Hi, let's solve today's daily challenge, that is largest divisible subset. In this question, we are given a set of distinct positive integer nums and we need to return the largest subset answer such that every pair answer of I and answer of j of elements in the subset satisfies this condition. And if there are multiple solutions, we have to return any of them, right? So what is the question? So let me take a test case here. So let's say we have 1, 5, 2, 3, 4, 7 and 8. So the test cases and questions are like quite easy, so might not make very much sense, but let's see with this test case. Right now, in this test case, I need to find the largest divisible subset, right, where this condition is followed. So first of all, let us understand what is a subset first, right? So a few people are always confused about what is a subarray, what is a subsequence, and what is a subset. So subarray is a contiguous part of the array. So if I consider this array, it is 1, 1, 5, or 5, 2, 2, 3, 4. That is, you cannot skip any number, as well as the sequence has to be maintained, right? It is contiguous, and sequence should be maintained. If we talk about subsequence, so in subsequence, we do not care if the part is contiguous or not. For example, it can be 1, 2, 4. So 1, 2, 4 is a valid subsequence. 1, 5, 2 is also. So all subarrays are subsequences, but not all subsequences are subarrays, because in subarrays we can 1 to 4 cannot be considered because it's not contiguous. So that is the definition of a subsequence, but the order is important. You cannot write 1, 4 and 2. So this is not true, but it is in a sequence, right? You cannot break the sequence. If we talk about subset, then it does not follow any of these two conditions. That is, it is first of all, it can be contiguous, it cannot be contiguous, it can be sequential, it cannot be sequential, right? So 1, 4, 2, is it a subarray? No. Is it a subsequence? No. Is it a subset? Yes. So that is basically what a subset means. So now I hope the meaning of subset is clear. Now let us see what the question is asking us to do. So here we want to find the largest divisible subset. So if I just simply sort this array, right, then it wouldn't have any effect on the subset that we want to find, right? We will still be able to, but in these two cases we cannot do sorting. Okay, so let me sort the array. We have 1, 2, and then 3, 4, 5, 7 and 8. These are the numbers that we have. Now what I have to check, largest divisible subset. So that means that array of I, right, should be divisible with array of j, and the vice versa should also be true. So now in this case, if I start with 1, right, and check with 1 and 2, so 1 and 2 are all right, and if I keep going on along this way, right, 1, 2, and if I come at 4, so 4 divides 2 as well as 1, right? So I can include 4. Then similarly 8 divides 4, 2, 1, all of these, so we can include this. So this is a valid answer. Now if we see 1 and 3, let me change it to 6. Okay, if we see 1, 3, 3 divides 1, and if we take 6, so it is also a valid subset. Then we can also have 2, 4, 8, but that is essentially here, right? So we'll not consider it. Then we can have 1 and 5, and all right, and the last one would be 1 and 5 here. So among all these possibilities, you can see this one has the max length. So this is the largest subset that we can find which is divisible, right? So all the pairs must be divisible by each other. That is, 1 should be divisible by 2, 4, 8, 2 should be divisible by 1, 4, 8, 4 should be divisible by 1, 2, 8, and 8 should be divisible by 1, 2, 4. So that is the largest divisible subset, and it is being followed here. So we have to return this subset. We have to return this subset as an answer. Now Now let us see how can we solve this question. So if you think about the brute will be to calculate all the subsets and check their validity, and out of the valid subsets check which one satisfies the question's requirement, that is which one is the largest. Now let us try to form an answer here before we jump to the approach, right? So if you see, what I'm essentially trying to do is I take an element. Okay, let's say in this case I take 1. If I take an element 1, then how do I check if the next number or whichever index I am at is going to give me an answer? So I'll check 2 if 2 divides 1, right? Or 1 divides 2. But in this case, as I see, I have sorted the array, so I don't necessarily need to divide 2 by 1, right? I can simply do 1 and I can put 2 here, because 2 by 1 I can simply calculate instead of checking for vice versa, right? There's no requirement because it is already sorted. Okay, then we move ahead and we come to 3. So right now we are considering this as my subsequence, right? So if I am considering this as my subsequence, then obviously 3 doesn't satisfy this condition, that is 3 by 2 is not divisible, correct? Then we come to 4. So we simply calculate 4 by 2. Okay, 4 by 2 is equal 0. So I can include 4 in my answer. Now here, if I have already checked the divisibility of 1 and 2, right, and I have checked the visibility of 2 and 4, so can I say that if this is true, that 4 is divisible by 2, then 1 must also be divisible by 4, because 1 is divisible by 2, correct? So this is the main observation here. All right, so we have 1 2 4. So we don't really explicitly need to check for 1, because I've already checked for 2, and for 2 I have already checked before. Similarly, if we come to 8, I'll try to calculate 8 by 4. 8 by 4 and not 8 by 2 or 1, because 2 and 1 are already divisible by 4, right? So I only need to check 8 by 4. Amazing. So I'll include 8 in my answer. So this is how I am forming an answer. So I'm saying first sort the array and then try to figure this out, that if whichever number you're standing at, can you append this? So this is quite similar to LIS. What is LIS? Longest increasing subsequence. Now how LIS is beneficial for us in this case? It is because in LIS what we basically do is, let's discuss LIS here first. So let us take the same array, that is, let me take this particular array. We have 1, 5, 2, 3, 4, 7 and 8. And I need to find longest increasing subsequence. We already discussed what a subsequence is, right? It should be in sequence, but it does not necessarily need to be contiguous, right? We can pick any elements. Alright, so in LIS what we do is we try to find what is the longest increasing subsequence. So there can be many subsequences. Which one is the longest and increasing? Okay, so that means 5 2, if I consider, is not increasing, right? So it's not a part of my answer. So the part of my answer can be 1 2 4 8, correct? Now if we start with 5, I can only find 7 and 8, so its length is 3. This is also longest, this is also increasing subsequence, but is not the longest. Similarly, if we take 1 3 7 8, so this is also a possible answer, right? 1 3 7 and 8. Oh, this is 3, this is 7, this is 8. Right, now if you try to check for other solutions as well, it would be 1 2 4 and 7 8, right? So we have to include a 7 here. So you can see this is the longest increasing subsequence in this case, and its length is 5, right? So this is the LIS problem. Now how do we solve this LIS problem? In that only approach our answer to the current question lies in. So in LIS what we do, this is essentially a DP problem. Okay, so I will not go in very depth and everything in LIS. I will simply discuss the DP solution here with you and try to show you how it's similar to the current question that we are solving. So when we use DP here, right? How do we create the DP array? So we say that this is my DP array and it's of the same size as of my LIS array. Okay, and this is my DP array. Now what I say that what my DP of I denotes is that with this particular element, what is the longest sequence that ends, right? Okay, now let me try to do a dry run for you. So initially we have this one, so its length is 1, right? So the maximum length in this case would be 1. So I'll fill my array. Then I come to 5. So now what I check is up to this index, right? Whatever subsequence I had, so it was 1. I try to check if with this subsequence I can append the element I'm currently at. So I can see I can definitely do that. That is 1 comma 5 I can do. So now that makes the length of the subsequence 2 for me. So I'll store 2 here as the maximum value. Then I will come at 2. So for 2, I will check all the elements left to it, right? And take all these elements and go to their DP, okay? And also compare 2 with them, right? So I can see that 5 is greater than 2. So this definitely, this index would not give me an answer. So I'll move to this index. And with this index, I will check the subsequence ending with this index. Can it be appended? Can 2 be appended to it? So definitely, because 1 is less than 2. So I will say what? Simply add 1 plus 1. That is this element to this subsequence. So here also I get 2. Here I also get 2. Then I will come at 3. Okay, I will come at 3, and again for all the left elements I will check which of the subsequence I can append it with, and after appending or try to append with this, what is the maximum length can I get? So if I append it to 2, can I append it to 2? Yes, because 2 is less than 3. So I will do 2 plus 1, that is 3. So we have 3. Then can I append it to 5? No, because 3 is less than 5. So it is not increasing then. So this will not be considered. Then we will come to 1. So with 1, we have 1 here in the position. So we will have 2 here. So out of the maximum, out of these the maximum is 3, so we'll include it. Then we will come at 4. Then again we will check all the left side elements and check what is the can I append this 4 to any of these sequences. So if I see 3, I can append it to 3, correct? So what will happen now, I will add 1 to this index. So I'll get 4. Then I will check for 2 as well. So I can append it 2 also. I can append it to 1 also. So if I append it to 2, I get 3. If I append it to 1, I get 2. So out of these, the maximum is 4. Then we come to 7, and at 7 again check all the left side elements and check if we can append this 7 to the subsequences, right? Ending with this element, or this element, this element. So I can see I can append it to all of these elements. So if I simply add 1 to all of these and calculate the maximum. So if I add 1 to 1, then we get 2. For 5 I get 3. For 2 I get 3 as well. For 3 I get 4, and for 4 I get 5. So out of the maximum is 5. So this will include in our answer. So this block is not included. And then for 8 we will check again, try to append it with all. Since 8 is already greater, so I can say 5 plus 1 will be the max. So the longest increasing subsequence length is 6 here, and this is the dry run. Now here in this question, after sorting the array, we are essentially trying to do the same. So we made 2 observations here. First of all is sorting the array. Why? Because it reduces this array of j modulo array of I for us, right? We don't have to explicitly check for the second condition because already the first element is greater than the second element is greater than the first element. So that is my first observation. So I can sort that in. Also because it is a subset, right? So the sequence doesn't matter. Then we saw that we don't have to check for all the elements that we have already included. We have to simply check if this 8 can be appended to this 4, right? The subsequence that is ending with 4, can 8 be appended to it, right? So that is very similar to LIS, right? That is the essentially the very same thing that we are doing. In LIS, we are only checking if the element that we are trying to append an element to, is it greater than it? But here we are simply checking if it is divisible by it. Correct. So that is the similarity. And now all I have to do is apply the logic of LIS to solve this question, right? This is essentially LIS only, but the condition for LIS is to check between which element is greater, right? For example, if 4 can be appended to 3, 4 cannot be appended to 5, right? And similarly here we are checking if 8 can be appended to the subset ending with 4, right? And I have to simply check the divisibility of 8 by 4, right? And not by 2 or 1. So this is why we can solve this question using LIS logic. Now in LIS, another thing is, here this array is telling me the maximum length of the subarray. Now how am I supposed to know which of these is that subarray that will give me the maximum length, right? I need to return answer as 1, 2, 3, 4, and here 7, 8. Correct? This is my answer, right? And how am I supposed to get this? So for that, we will create a backtracking array of the same size, right? And initially the values inside of this will be that, see, what is the maximum LIS, right? That ends with this index. It is 1. So initially the DP array should have all the elements maximum is 1, because if I only include this element, then also I get an LIS, right? But that is the minimum. I have to check for the all other possibilities, correct? But here inside the backtracking array, they have to be initialized with the index that they end with. So they will end with their index only, right? So if it is 0, so if I talk about 1, right? So it index with its 0, its index, right? So we get 0. And similarly for this 5, right? Initially, if I talk about 5 ends with what? What is the last index that 5 ends with? So it will be 1 only, right? And similarly, we'll have 2, 3, 4, 5, 6, and we will put it inside of our answer. Oh, sorry, in our backtracking array. Now how is it going to be useful? See, now what we are going to do is, see, this backtracking array is only going to return us. So first of all, let us understand what this ith index actually represents. Here in the DP of I, it was representing the length. Here it represents the index, the last index of that subsequence, correct? So let's say for this case, it will be 0 only, right? If I come to this case, what will it be? It will be 1, right? If I come to this case, right? If I come to this case, then it is 4, it is 2 here, right? So what is the last index? So I will store 0 here, correct? 0 here as well, so that after coming here, right, with this index, I will go to 0. So this essentially means that 5 and 1, this is the subsequence. If I come to 2, if I come to 2, then what will happen? It is 0. So I will check the index here. What is the index present? 0. So I will go to that index, and that will be my subsequence, right? So it will be 2, and what is present at this index? It will be 1, right? So this is how we will get these answers, right? Similarly, if we come to 3, right, what was the element here? The element is 3 only, right? So for 3, so the last index, this subsequence ends with this 2, correct? So if I take this index 2, so I will take, okay, first I'll include this, right, this index. So this index is 3. Then I'll say go to the 2 index. So 2 index is 0, right? And then go to the 0th index. So I go to the 0th index and include it. Sorry, this will be 2 only here. because the element stored at this index is 2 and then 1, correct? So this is the subsequence that I'm getting. Similarly, if I come to 4, what is the value here? It is 4. So if it is 4, I'll store the last index of the subsequence, right? So iterating here, I will check where am I appending this. So I'm appending it to this index, 3 index, right? So I'll store it here. So I'll store 3 here. So what will happen now? I will get with this index. First I'll include this in my answer, so I get 4. Then I include, I'm saying go to the third index, so at third index 3 element is present, so we go to 3. And then at 3 index I say 2 is present, so go to the second index. Second index contains 2, right? And then this 2 index is saying go to the 0 index, that is 0th index contains 1. So this is the increasing subsequence that we are getting, right? Similarly, if we come to the last element of the subarray, I will get the index as, how many elements are here? 1 2 3 4 5 6 7. So this will be my last index. So at 7th index 6 index would be present, okay? And similarly, using this, I will go to 6. I will go to what is present at 6th index, it will say 5. And I will go to the 5 index, what is present here? 4. So then I will go to the 4 index, then to the 2 index, then to the 3 index, then to the 2 index, and then to the 1 index. So it is 5 that we are leaving behind, and you can see here as well, right? So this way we will be able to get our answer here. All right, so now let us go here and implement it. Okay, so first things first, I have to sort it because I can, as it is a subset. And also the reason it's useful to sort is that we don't need to check for the second condition, right? I don't need to check vice versa. And I will simply take the size of the array, that is n, and nums dot size. And after that I have to create this bt array, backtracking array, and the dp array. So both of these are going to be the same size, that is n only. So then we'll create vector int dp of size n, and as I said, the longest see, we can always include that particular element in the answer, so 1 is going to be the minimum. So we'll initialize the whole array with 1, and after that we'll take this bt array and with the same size. Then we have to take 2 more elements, that is 2 variables, that is max length. Max length will help us to store the maximum length of the subsequence or the subset. So it will be initially be 1, and then I need this index also. So for the last subsequence, now in this case what happened was it happened at this particular index. Now it is also a possibility that it can happen somewhere in between, right? And that is my longest answer. So that is why I need to keep track of the last index that I have to access, right? Now let us go ahead and write the dp. So we'll say for int I is equal to 0, I less than n, and I plus plus. So dp of I is already initialized, right? So but still I will initialize it with 1 just to show you that minimum possible answer can be 1, right? That element itself. And bt of I, as we discussed, has to be initialized with its index, that is whatever subset that we are considering, right? If its length is 1, if we are only including that element, then it ends with its index only, right? Okay, then we have to iterate for all the left elements. So we start from int j is equal to 0 and j less than I, all the left elements, these are the left elements, right? 0 up to I index. And we'll do j plus plus. And in LIS, what we do, we compare that if this I element, that is nums of I, is greater than nums of j, then I can include it as an answer. But in this case, we are checking for the divisibility. So instead of checking if the element is greater or not, we will check if the element is divisible or not, right? And as we discussed that we don't really need to explicitly check for rest of the elements in that subsequence, but the last element. So we'll simply write that if nums of I is divisible by nums of j. And also we have to include this as an answer if 1 plus dp of j is greater than dp of I. Right? What does that mean? That means that if this means I am including this nums of I element with my subsequence that ends with j, right? If I'm appending, then it becomes 1 plus dp of j, what is present at this index. And if it is greater than what we have stored in dp of I, then that means I have to calculate it, right, and store it at dp of I for further iterations. So then I'll say dp of I is equal to dp of j plus 1, and here we have to also take this index in bt of I, right, so that we can go to this index. Okay, after this I have to check. Okay, I have to check, right, if dp of I is greater than max length. See, now what we are doing here is we are checking overall all the possibilities, right? And in maxillion I'm saving all of the subsets that I have traveled, right? Out of those, up to this I index, what is the maximum length of it, right? For example, here as we were progressing, we saw this is the max length subset, then we saw this is the max length subsequence, then this is all the same length, but here it is 3. So this particular subsequence that ends with this is has the maximum length. Then we keep on increasing and going, and here in the last index you can see we have an answer, right? So this we have to include, right? This we have to include, because what can happen is, as I said, in this case it happened that with the last index only the subsequence was ending, but in some cases, for example, let me give you an example, right? I'm just talking. So let's say it's 1 2, and let's say let's not include 1 2 here, let's include 5 6 1 2 3, and let's say, yeah, that is it. Not 1 2 3. Okay, let me say this is 5 6 7 and 1 and 2. Here if you see, what is the longest increasing subsequence, it is 5 6 7 and not 1 2, correct? So this answer ends at this index, so I would be having this max at somewhere here. If I just form the LIS array for this, DP array for this, it will be 1 here, it will be 2 here, it will be 3 here, 3 here, but here at 1 it will drop down to 1 again and 2. So out of this is the maximum, right? So that is why I'm taking this max length, so that among my iterations I also keep calculating what is the maximum length and what also store at what index it is at, right? So that we can also form our bt array, using bt array form an answer, right? Because if we go up to this index, then we would be getting wrong answer, which is 2, correct? We have to calculate for this, so that is why we are taking maxillion. And then we have to update this max length as dp of I, as well as, oh sorry, the index variable that we took, we have to take it as ith index, so that we, when we iterate in the inside of our backtracking array, right, we can go and get the sequence, right? And this represents the last index of the subsequence or subset. All right, after this for loop, right, we have done iterating. I have to iterate in the bt array, right, and get my values. So how am I supposed to iterate? Let me first take in an answer array in which I will include all these elements, and then first, as I said, push that element, right, that is present at index ind. Okay, so we'll say nums of ind will push, and then we'll iterate while bt of ind is not equal to ind itself. Okay, and then what I have to do, I have to simply say ind is equal to pt of ind. Please move to the index, make this index equal to what is present here, right? What is present here. And then we will go to ans dot pushback nums of ind. Okay, now what I am doing here is that this condition checks go until this bt of ind is not equal to ind. Here if you see, our last, this subsequence ends at this index 0, right? And here 0 and 0 are same, that is bt of ind is same as the index, so I have to stop here, correct? If I try to form the array here, here also it will be 0 only where we go and stop. If I take this as 5 6 7 later and 1 2 as before, let me write it here. Let's say I am trying to form this bt array for this. So this is with regard to LIS that I am discussing, okay, so that it's easy to understand. So the dp array, we already know what it will look like. Okay, actually it's all of it is an answer. So let's not take this case. Let me take one. Let me take here as 3 and these values as 1 and 2, and here let's say this is 9, 3 4 and 5. Let's say we have something like this. Okay, let's take this as 6. Okay, this is 6. Now let's try to form the bt array here. So we have 0 1 2 2 3 4 5 numbers. Now here if you see what is the LIS is 1 4 5, so I should be getting 1 4 5 as an answer. So if I iterate in the bt array, let me first form this bt array and then try to iterate, right? So for 5 the last index should be 4, oh sorry 3 here, right? And then for 4 it should be 1, right? So I should go to 1. And here 9, for 9 it's 6 and 9, so I should go to 0 index. And for 1, where should I go? This index only. And for 6, where should I go? This index only. Now if I see, it is the maximum that is giving to me, right? This is the index. So in ind variable this will be stored, and I'll keep iterating. So from 4 I know I have to go to 3 index, so I'll go to 3 index, I'll get 1. Then I'll go to 1 index, so I'll get 1. Now 1 and 1 are equal, so I have to stop, right? So that is what the condition we are checking here. So we are checking this here, and then we are only iterating and putting the answers and including in our answer. Now we can simply return our answer as it is a subset, right? If it was a subsequence, then we would have to reverse the array, right? And also the sort wouldn't be there. So that's it. Let's quickly run it. So it's accepted. So this is basically how we have to solve this question. Now if we discuss the time and space complexity for this, so space you can already see will be big O of n because we are using dp and backtracking array. And if you see the time complexity, it would be big O of n square. Why? Because we are simply iterating in the array, as well as we are then iterating for the left elements of that particular index, correct? So it becomes big O of n square. So the time complexity is big O of n square, space complexity is big O of n.